Hello, everyone. Welcome to this session of AWS IoT. Uh, Without any further ado, I would like to introduce our speaker, Sufian. Hey, Sufian.
Hello, Karthik.
Sufian, uh, give us a brief introduction about yourself and the topic we are going to do today.
Sure. So, my name is Sufian. So, uh, electronics engineer, uh, been passionate about IoT since I think like 2013. So, have spent quite a lot of time in building all these things. Only in 2013, I think like IoT became very popular. So, before that, it was all connected embedded device and stuff like that. So, after that, like I did my master's. Now I work for several companies around the world trying to help them build IoT solutions that will help them in digital transformation and all that stuff. So uh, for last 2 to 3 years, I have been using AWS, and then before that, I used to build my IoT solutions on my own, deploy my own server, have all the pipeline, everything. Like we will talk more about like what kind of services are we going to deal with. But yeah, I would prefer I would be like a private cloud person. But after I explored AWS, and then most of the companies today, they are very conscious about like how well will the solution be scalable. And when we talk about scalability, that's where a cloud solution, especially like AWS, has its unique set of features. So along with that, the power for a lot of companies to build IoT devices or IoT solutions becomes very interesting, and it really has a lot of potential. So today we will talk about like what is IoT, little intro to it, and then we will talk about what kind of services does AWS offer. Plus, we will also look at like a live demonstration of how devices talk to the cloud, and then how we can perform some analytics on the cloud. Then how can we build applications where we can monitor the IoT data.
Okay, wonderful. So, could you please share your screen, Sufian?
Sure. Share screen. Oops. Like my browser wants me to. Oh, can you see my screen now?
Yeah, it is here.
Okay, great. So I need to go away, and then here is my presentation.
Okay.
So
Okay, so
do
okay, I'll go backstage now.
yeah, sure. Thank you, Kar. Just a second. We will talk about what IoT is. I also work for a company in UK called IN4 Group, where I train some of the people there, and then I'm also a IoT Solutions Architect there. Now, what is IoT, the buzz all about? I'll not take too much time for the intro because I also want to show you some really interesting stuff. Now, network of connected devices. So that's what internet is, which is fortunately like all the kinds of devices, computers, smartphones, wearables, talk about anything, we consider all of them to be devices. So what's different in internet of things then? Are these devices computers, smartphones? Are they not things? So how different is IoT? If IoT is something different, what about the existing internet? That's where the answer is like in the other devices like computer, smartphones, what we essentially exchange is information, and information does not act on the devices. It's just like internet of information. Now, in Internet of Things, what also happens is like these devices, when they get access to the information, they get to sense the environmental aspects, or they kind of actuate something on the environmental stuff. So, in addition to exchanging information, it also has the ability to kind of like interact with the environment. So that's how we can call an IoT device to be like. Now, when did it start? Like Kevin Ashton in 1999, he was working for PwC when he was giving one of the talks in North Carolina. That's when he coined the term IoT in the context of, can we identify every object, be it whatever, like be it like your shoes, your card, your wallet, your specs, whatever it is, can we uniquely identify each of these objects? So back then, RFID was a thing. Even now, it's used in a lot of places. So if we were to identify each of these things, can we exchange information with those things? So that's where RFID, in the context of RFID is where IoT became very popular. No, but IoT is like a confluence of several technologies, because like one fine day, uh, every industry started associating themselves with IoT. But most of the things that we deal with in IoT, it has been there forever. Like talk about compute, talk about communication, networking, security, sensors, all that stuff. Now, a combination of all this technologies is what enables Internet of Things. So a simple IoT solution, the way it looks like, is like there are IoT devices. It could be anything, essentially anything, like wind farm, coffee pot, door lock, talk about anything. So all these are things, umbrella, it could have been anything. Now, we want to make it smart. We want to exchange information with that so that we can make smart decisions. Now, most of these devices that we talk about, we want them to last longer. We want the battery, we want them to last longer, because there are IoT devices. Take wearable gadgets, we want the lifetime or the battery life to be as long as possible. There are IoT devices. I'm not sure if you have heard of it, like Bluetooth beacons. Uh, it has a lot of use cases in supply chain, in retail store. So whenever a user passes by those beacons, it's a Bluetooth beacon, any Bluetooth receiver, essentially a smartphone, it will catch that message and show you an advertisement. Things like this is like very popular in malls these days in India. But yeah, that's what it's supposed to do. Now, we want to extend the lifetime of that as long as possible, which means we do very less compute in there. We don't communicate with internet, because if we do those things, the battery life will be less. It will get shorter. So what we do is like we do very minimal things in the IoT device, but most of the communication to internet or high-end processing, encrypting the information, all that stuff, we do it in something called as gateway. The gateway can be as simple as your smartphone or your Wi-Fi router. It could be anything that essentially lets these IoT devices to talk to the internet. This communication between devices and gateway could happen in a secure way, insecure way. It's up to us. But after the gateway, when we want to push data to a server, these servers could again be like a company's proprietary server, or it could be a cloud solution. Now, we can send all that data to the server. From the server, when it receives the information, it acts upon it, it stores it, and there can be applications that talk to the server or the storage of all the IoT information, and then they can we can build dashboard, we can send email notifications, or we can control the IoT devices. So it's up to the application how we want to configure it. And so this is how like an IoT system usually works. Now, some of the things about IoT devices, they are resource constrained. Like I said, they don't have enough power, they don't have enough bandwidth to communicate to the internet. Computation, again, it's limited there. We can do a lot of stuff there, but trying to get a lot of work done from IoT device, it will only end up the device consuming more power, which means the battery life will become lesser. You can consider wearables to be like a very classic example. We want our wearable gadgets to last as long as possible before we put that out for the next charge. Now, those devices, they don't usually connect to internet directly. They create a Bluetooth connection with your smartphone, and then that talks to the internet. So that's one of the ways of how we try to keep the balance between the IoT device and the gateway, as simple as smartphone. It should be compact in size, low cost, programmable and reconfigurable. Although, like, these are very critical aspects of how a company will think of an IoT device, because when we talk about any solution, we will first come up with the requirements, and when we dive deeper into that, a lot of possible solutions come up in terms of selecting the microcontroller, the power, circuit, the battery size, connectivity, and all that stuff. But overall, in general, like, these are the things we want to address. Some of, I mean, one another reason why IoT devices, IoT systems have become so popular, why the world is like adopting IoT as a technology very rapidly, is because the technologies to get started with IoT is has a very like low barrier. The devices, there are so many prototyping device. You might have heard of Arduino. There is like an implementation of Arduino, which also has Wi-Fi, Bluetooth, all that stuff. Because it all, I mean, these devices also needs to connect to some other wireless communication device most often. So we could use that. Raspberry Pi, another classic example of how we can attach sensors to it. We can run a full-blown Linux operating system into a Raspberry Pi board. Costs around $35, but the power that we get from these devices is like enormous. And this is my favorite, which has been doing a lot in the market recently. It's called ESP32. It has Wi-Fi and Bluetooth inbuilt. There is an special operating system for this. Even AWS has worked with one of the companies called M5 Stack that uses ESP32 and builds like really nice looking IoT devices. This is what I'm talking about. It's called M5 Core 2 for AWS. I also have one here. I'll show you a demo with this. So that offers a lot of ways of how we can program it. People who are familiar with text-based programming, they can do it that way. But if they are not familiar with text-based programming like C, C++, MicroPython and stuff like that, there's a GUI way also, GUI method of programming these devices as well. That's what I'll use today and show you. Again, this is like, this has a lot of peripherals, because getting a microcontroller alone is not enough most of the time. We need some sensors along with it. It's good if it has a display. These devices like M5 Core 2, and there's one more implementation of M5 on ESP32, which is called Stick C+. This is also like a really nice device. So what I'm trying to say is like, there are so many IoT devices these days that for someone to build a solution, it's like, it does not take too much effort. And that's the reason why a lot of prototypes are being built, proof of concepts are being tested, and the solutions are getting built and deployed in the market. Now, as IoT itself, like as a technology, what it can do is like either sense something or control something. Where does the application actually lie? It's in its integration to work with other domains like this. It can work with AI ML. So whatever data we collect, we can run machine learning algorithms on it, and then kind of aspire for solutions like anomaly detection, predictive maintenance, which means a lot to a lot of manufacturing industries these days. We can use it with drones, 3D printing. I can go on giving like an example for each of these things. But what I'm trying to say is like, IoT, when it works with other technologies, that's where it's able to bring in a lot of value. And I just wanted to share this one article with you as well. Like, Industry 4.0 is being talked about a lot. There is an article recently that I came across a couple of weeks back. So that talks about how IoT is set to overtake cloud computing as primary Industry 4.0 technology, which means like the budget companies have been allocating to different technologies. Now, a few years back, so it was like in 2016, I think, like the budget for IoT was around 7% in terms of how organization budgets for different technologies. Now in 2020, after the pandemic and stuff like that, IoT is like on the top. where companies want to spend around 10% of their IT budgets. Then comes cloud computing at 9%, then security, big data analytics, robotics. So it goes on. So IoT, I mean, like, although it's in nascent stage in terms of a few things, because there are a few challenges still existing in IoT domain, but the way the future, if we look at the future, there's a lot that uh, IoT brings in to the industry. Now, there have been uh, three generations of industry already. So, what is IoT bringing into Industry 4.0? It's essentially like predicting the future, or being able to let the devices decide what's best for them by themselves. Until Industry 3, we were trying to automate things. We had dashboards, we were looking at the data, but it would be essentially like some human at one or the other end making the decisions. Now, in Industry 4.0, we are giving the control to the machines itself, so they can plan, and then they can manage our business and those solutions better. And IoT devices, again, like, this is one another good example of how Industry 4.0 allows us to like get data from several places. From production line, we can get real time analytics of how the machine is working, what products are being manufactured, and how does that production line look like. In addition to that, we can fetch information from ERP, management execution system, manufacturing execution systems, quality control. We can bring all of that to a data lake, and then from there we can run algorithms and learn more about the anomalies or predictive analytics. So that has a lot of value these days. And although like a lot of people have been working on these kind of solutions, but every company, every manufacturing industry, they have their own unique problem statement. So that's the reason why, like, doesn't matter how many number of times companies develop these solutions, every industry has their unique needs. So the customization takes a lot of time. We can use IoT for blockchain, for supply chain, logistics management, for cryptocurrency, all that stuff. But since I want to also talk about a lot of other things, I'll just like go through these briefly. Put these IoT devices on drones, which you can control from anywhere, or you can monitor that from anywhere. AR, VR, this is like, again, maybe I would say another 3 to 4 years, we will see a lot of applications of IoT in AR, VR, because a lot of companies have already started working on it. The floor managers in manufacturing industries or in the training companies, they don't want people to carry a lot of devices, or they don't want to have a lot of machines in the factory environment. Instead, every user, they have their own device, so wherever they go, they just like scan the RFID code, or look at a QR code, or just like scan the machine that uses the AR part, and then the application talks to the IoT systems and then pulls in all the data relevant to that machine, that talks about the health of the machine, the productivity of the machine, and all that stuff. So coming to like, where are we still lagging in terms of IoT security? Um, Although there has been a lot of work, several companies implementing a number of things, a challenge about Internet of Things is like it also needs to have interoperability. So when we talk about interoperability, like, devices could have been like manufactured by different companies, and they could have been configured using different technologies, in the sense backend, how they communicate with their servers and stuff like that. Now, finding a common solution in terms of security for all these devices, that's the challenge there, because like most of the companies who are supporting IoT deployment in a large scale, they have a solution of their own. But is that the solution every other company as well is using it? Not really. That's where security is lagging. And for every problem statement in IoT, we need to customize the solution. So the architecture essentially varies, which means like for every solution we want to build, we have to build a custom solution. And when we talk about like too many devices, a company wanting to monitor a lot of stuff, maybe remotely, maybe within the factory, how do they manage their devices? Like if they want to send an update to these devices, if they want to reset a device, how do they reconfigure, reprogram, all that stuff? So doing this device management is a challenge on its own, especially when we talk about like large systems. And edge computing, not all the time the IoT devices need to talk to cloud, because maybe two devices from the same room, from the same factory floor, want to communicate with each other. It's pointless for them to send message all the way to the cloud and get back those messages. Or when there is like intermittent connectivity, there is a lot of problems that can happen with IoT solution. In order to save the battery, we put devices to sleep mode. So a device could send message, the other device, to conserve its energy, it could have gone in sleep mode. Now, how do we ensure the messages are being sent? If we keep sending data all the way to the cloud, there's bandwidth issues, there is power issues, there is internet issues, it could be anything. So can we bring some components of what we can do in cloud to the local uh, environment? When I say local, like in the factory floor, or it could be your smart home solution, it could be any other solution. So can we bring in some capabilities of cloud locally? That's what edge computing is about. And so a lot of organizations are working on this. And fortunately, AWS have, okay, and data analytics as well. Like we generate a lot of data. What do we do with that data? Although like several organizations are working on these challenges individually, some of them are looking at it collectively, building solutions. AWS, through different services, it's addressing each of these challenges. So that's what we will look into. Any questions at this point of time, or do we take questions in the end?
Yes, Sufian, we take questions at the end.
Sure, thank you. Okay, so how does AWS uh, have its IoT solutions, and how do we work with that? All the services that AWS offers, it tries to address something called as IoT universe that it has created. So IoT devices can be used at home, at work, in the community, and the services AWS creates, like it tries to make it relevant across the universe. So we will see some of those services in action or conceptually, and we will see how it fits into uh, the different parts of the universe, which is essentially home, work, and society. The categories in which AWS has put these services, it starts from device software. So this talks about how we can get our devices connected to the cloud. So how can I connect my devices and operate at the edge? So from wherever we are, how do we configure the devices? And in terms of control services, it talks about like how do I ensure on the cloud platform I can control the devices that I have in the edge, manage them, and secure those devices. And once the data goes to cloud, we have data services that talks about like how can we extract value out of that IoT data that goes into the cloud. Now, the services that are there in these categories, this is how it looks like. In terms of devices, we have AWS offers a version of free RTOS, which is meant for, uh, it's like operating system meant for a lot of devices. We can find for whichever architecture we want, and then we can configure it so that these devices can connect and talk to AWS IoT Core. And if we are not going to use free RTOS, or what if we want our mobile phone or any other device to act as a IoT device? So AWS also offers a lot of other SDKs in Python programming language, in Node.js. So there are a number of them. So we can use those SDKs as well to connect to the cloud. People who are passionate about Arduino, like, yeah, we can use, there is a IoT device SDK for Arduino framework as well. We can use that, so we can configure our devices to connect to cloud, and then we can communicate to AWS IoT Core. When we want to bring edge capabilities, like build a edge computer on local server, we can use Greengrass service. When we build or when we develop FreeRTA software, we want to check how well is the software working. We can use device tester for that. That will check, like, is the device or is the software that's meant for a particular device, is it configured properly? Are there any security lags, performance lags, all that stuff? So these are the things we can do on the device side. And after we configure this, in order to connect to cloud, first we usually use like device management, but device management is part of IoT Core. So we kind of configure, like, first what devices do we want to create, and then we create those security certificates, put them into the devices, and those devices now are ready to connect to IoT Core. I'll talk more about IoT Core, what does it essentially offer. And although we have certificates, we have a lot of policies that ensure the right device talks to the right service. What if there is like an abnormality? Two devices trying to communicate to the cloud with the same name, with the same certificate, or the device suddenly changes its IP address, moves from one location to the other location. Is there a way we can track all those things? That's where device defender comes into picture. So we can use device defender for that. And when we get all the data to the cloud, which is IoT Core, from there we can get the data. I mean, that data, when we want to perform analytics on it, there are a few services. I'll use IoT Analytics today, but when we want to kind of create like a chain of events for IoT devices, we can use IoT Things Graph. When we want IoT devices to trigger other AWS resources, we can use IoT Events. And IoT Sitewise is another service I'll talk about as well. Let's start with connectivity. So how do we get started from the AWS cloud side? Now, IoT Core is like the basic service, which, I mean, where we try to communicate our devices to. So the devices can either publish or subscribe. This is a little bit different from how normal web communication works, which means we usually like send message. I mean, the client sends a request, the server sends a response. Whereas in MQTT, instead of going with the request response model, we have something called as publish and subscribe. So the way that works is like there is going to be an MQTT broker. The reason why we use MQTT as a protocol instead of HTTP is because HTTP takes a lot of uh, bandwidth in terms of exchanging the messages. More than the message size itself, the HTTP packets headers are more sometimes. Let's say if I have like a sensor data that I want to send, maybe my data packet itself is like 20 bytes, 30 bytes maximum. Now, in order to send that packet, the overhead packets that we exchange in HTTP, that's too much comparatively. That's the reason why MQTT has been brought in, so that there shouldn't be a lot of overhead data on packets than the actual data itself. So any device, when we want to connect to broker, so again in MQTT, instead of calling it as a server, we call it as a broker. Devices can either publish or they can subscribe. So it's like how newspaper subscription works. So whenever we subscribe for a newspaper, the newspaper man like every day brings in those newspapers to us. Similarly, like devices can subscribe for a particular topic. Now, whichever device has subscribed to the topic, any device that's connected to the broker, when it publishes a message, all those devices that have subscribed will get that message. And the MQTT broker does not hold all the messages forever. There's a way how the broker can retain the last message on a particular topic, but broker itself, like if on a topic 100 messages were being sent, MQTT broker does not store all those 100 messages. By configuring certain things, we can make it remember the retain the last message, but not every message. So anytime that the message comes to MQTT broker, if we want to store that persistently, we need to run a script that takes those messages and stores it to a database or somewhere else. That's how MQTT works. Now, usually this is a challenge everywhere about security, how these devices communicate to the cloud securely. Three aspects of security most often: privacy. What if someone looks at the data? That's where encryption comes. So, whatever data we want to send, we will send it in encrypted format. The next thing is like, how do we ensure that the right device is talking to the right broker or the server endpoint? Now, in order to ensure this, this is where we have certificates. So, the device will like verify its identity by sending its certificate. The MQTT broker, or in our case, IoT core, it will send its certificate to the device to verify its uh, authenticity. What if someone changes data in between? That's what integrity is about. Now, for that, we use code signing, which also comes as part of the certificates. Most of the SSL certificates these days we use, it addresses all these three things. So, what's there in an SSL certificate? It has the domain name, and who verified these certificates, how long is it valid for, what's the public key for it, which the clients can encrypt their messages and send back to the servers. So how SSL certificates work, although there's like an attempt here, but if you are like really interested to learn how certificates work in your own time, my recommendation would be for you to like check out this website called how https.works. In a very graphical manner, it explains you what are SSL certificates, who issues them, why are certain sites secure, why and why are some not. Now, what happens in IoT devices is that only if it's not enough if the device verifies the authenticity of the server also wants to verify the device's authenticity. So both of them, they share the certificate, and they kind of convince each other that yes, they are the device whom they are claiming it to be, and they create a secure connection, and then they share all their messages. So SSL certificates, they use asymmetric encryption, which means as part of the certificate, the public key will go on to the device that wants to send data, but the only entity in the entire internet who can decrypt the data will be the device who is the owner of that certificate, because only they have access to the private key. And in order to ensure the integrity, did the message change in between or not? Because every packet that we send, the device, I mean, the packets go through a number of routers and a lot of networking devices. So before sending a message, the computer or an IoT device, it usually creates like a hash value, and then it attaches it to the packet and then sends it. If the message and its hash value don't match at the receiving end, then it means that there has been some problem in the transfer of the message. Maybe someone has modified in between, or certain packets are missing. So this addresses the concept of like integrity. Now, now that we talked about how we authenticate devices, which is basically it uses SSL certificates. Any device that wants to talk to the IoT core's brain, which is the MQTT broker, which we call as device gateway, it has to first authenticate itself, and then those devices need to have permission to perform actions on IoT core. Those permissions are usually defined in a policy, and that's what we call as authorization. Now, when devices want to connect, and if they have permissions either to publish or subscribe, connect, receive messages, it does a number of things. Now, after it gets connected, it can start sending or receiving messages. There can be any number of devices that can keep exchanging those messages. The devices that are provisioned in an IoT core in a particular region, all that is going to be available in the device registry, from where we can basically understand like how many devices are connected in a particular AWS account in that region. So what if we want to store the messages that the devices send? Because device gateway is like an MQTT broker. If we don't act on the messages that's on the device gateway, it will vanish. That's where a couple of other concepts come into picture, which is, do we want to perform any rule on the message that has come in, or do we want to store the state of the device using something called as device shadow? Because when applications want to either control or access information from the device, what if the device is not available at that point of time? Could be of any reason, no internet connectivity, or the device is in sleep mode to save its power. It could have been anything. So the applications can talk to device shadow, which is like a logical version of the actual device. So if they want to control the actual device, the applications can send a control command to device shadow. So when the device comes back online, it will know the status of device shadow and then it will adapt itself. If applications want to get data from the devices, device will have updated its data to device shadow, and applications can get that information from there. Other than device shadow, if let's say we want to create a notification or trigger a Lambda function, store the data in DynamoDB, S3, or wherever, we can create a rules. I mean, using the rules engine, we can create a rule where every time a message comes to device gateway, those rules will get kicked in and then they will perform the right action. There is like a really nice way of how IoT core works. So if you go to AWS console, go to AWS IoT service, on the left side, you can see there's something called as learn. And that talk gives you like a 5-minute tutorial of how AWS IoT works. Now, there can be multiple devices that connects to AWS IoT cloud. So depending on which button this device presses, the bulb changes its color. R for red, G for green, B for blue. And we can have rules. For example, whenever I press the blue button, this rule says that like whenever I press the blue button, it should automatically get converted to green. So now what will happen is like if I enable this, now that this rule is enabled, doesn't matter if I press B, it will automatically get converted to green. Green will also be green, but red will be red. A simple demonstration of how rules work. So in addition to just sending data to devices, using the same rules, we can also store the messages in or send a notification, trigger a Lambda function, or store it to some storage service. Could be DynamoDB, S3, or whatever. And when we expect devices to go offline like this, what I can do, okay, when it was online, if you see, it had a state red. I'll make this device go offline. Now I'll update the device status to be blue. So okay, because of that rules engine, okay, let me disable those. Now, when I say blue, the device shadow says like it has blue state. We know that the device, whenever it was last online, it was red in color. Now, when the device comes back online, I click on this, automatically it becomes blue because device shadow says the desired value for this bulb should be blue. Now, on top of this, like we can build a lot of solutions, have these concepts of rules, device shadows, and then build our own solution. And device management is where we can register for a new device that allows us to create certificates that we put onto the devices and then configure them. We can organize those devices into different types, different groups. So when we do put devices into different groups, Instead of attaching policy to a particular device, we can attach a policy to a group. So all the devices in that group will have those permissions. We can send updates over the air remotely and like get the output of all those messages as well. So these are some of the things that device management allows us to do. Device Defender, although we ensure security by exchange of certificates, permissions, still if something goes wrong, that's where Device Defender comes into picture. There are a couple of ways of how we can configure Device Defender. Either we create our own set of rules where we say, okay, if too many times a device tries to connect itself, but for some or the other reason, maybe it does not have the right certificate, it's trying to connect itself with a wrong client ID. So if it goes beyond a number of thresholds, like block that device or send a notification. So we can create, we can defend our IoT ecosystem by a set of rules, or we can let uh, an AI algorithm do its job. So AWS IoT has a number of algorithms that it wants to run on our IoT solution. And then if there is something abnormal that's happening, although we will select what metrics do we want those algorithms to be run on, it will uh, notify the IoT solution manager, like there's something wrong, maybe you want to look into that. And we want multiple devices to talk to each other. AWS also has something called as things graph. Now let's talk about the device software. FreeRTOS is like the operating system, real-time operating system that's given by AWS. We can take that, we can write our own firmware and then make that connect to AWS IoT Core. We can even make those devices connect to Greengrass Core, which acts like an edge computer. I'll show you the demo with this one. So for devices or people to connect to AWS IoT Core, these are the different methods of how they can do it. Either they can be an AWS user, so they can have IAM credentials through which they can connect, or they can have like device credentials, so certificates and all the required information through which they can connect to IoT Core, or they can do it through the Cognito identity. And this works on like several platforms, the device and mobile SDK. We can do it through Python or on a device or any other microcontroller which we can find in the market. Now, to get started with a default SDK, there's this option on the IoT console when you click on connect and get started. So click on get started. This gives you like a very easy way of how you can create like a simulation device in your computer that talks to IoT code. Select your operating system, whichever programming language SDK you want, and then you click next. You give your device a name, and it will download the software development kit. And it also has instructions. When you execute it, that will essentially start sending data to IoT Core. Now, what I will try to do is like I have this device in hand. M5, M5 stack, store stack. So this is a device that I have, and it has like a lot of stuff that's meant to work very seamlessly with AWS. Now, we can program it in a number of ways. The program that I will use is something called as UI flow. So either I can download the version of UI flow and then program these devices, or I can like do this GUI programming on the browser itself. Now I'm like just putting my device into programming mode. Okay, let me go to store, no, software UI flow coding IDE. That clicking on that link takes you to this website called flow.m5.stack. So this is the device. I have a few labels there. I have a button in there, and this is going to be my program. So I'm giving my device a name. Before that, let me first create a device in my IoT okay, AWS account. in Mumbai region. I have a few things. Let's ignore it. I'll create a new thing. Let's call that M5 core 2 underscore EME3 because the device can also connect to an environmental sensor from where I can program it. Okay, so I'll just call it that. And I don't want shadow for now. So I'll just click on next. Auto generate certificates. Yes. What policy do I want to attach to this? I'll create a policy which is like very generic. So for now, I'll say I'll create an allow all policy that lets the device perform all types of IoT operations, connect, publish, subscribe on any of the resources. Click allow and then create it. I'll go back to my thing and then, so this is the policy I'm attaching. Now let me download the certificates. I have my certificate, public key, private key, and the root certificate. Okay, so those four were the things that we need in order for our device to connect to IoT Core. Now, whenever the device sends message to our IoT account, like we also have to know like what's the endpoint where my devices have to send the messages to, publish the messages to. So this is the endpoint. So when you go to AWS IoT on the left, there is something called as settings. When you click on that, it gives you the endpoint where your device has to send messages to. I'll copy that and put that in my code here. Okay, this is my endpoint and I want to connect to this Wi-Fi. Okay, here I also need to like specify something. Okay, this is good. Let's refresh this. E2 E25F4. Yes. So this. My device seems not to be connected right now. I'll create a hotspot. It's already there. Restart my device. Put it into programming mode. Okay, this should hopefully get started now. Bear with me for a moment. I will create the hotspot. Meanwhile, let me just like walk you through the code. So these are the blocks that are available. So I can do pretty much anything. Like if you are familiar with Scratch, you may be familiar with this. Here, like with this device, I'm connecting a unit called ENV3. So when you click on plus, you will see like what are the different sensors that you can connect this device with. So when you connect these sensors, you will be able to get those values. Either you can, if it's a sensor, you will get values from that, or if it's like an actuator, maybe a servo motor, maybe a display device, LED, RFID, if it's anything like that, you will be able to control those items as well. Okay, so now my device is connected. Let me quickly like update the certificates in there. Manager here, I have the certificates already. I'm deleting them. And these certificates, like nowadays when we download things, you IoT code, they are like very lengthy. So I'll just like rename that. I want certificate a little less lengthier, and also the private key. Okay, now I will import those certificate into the device. Add certificate in desktop. From here, the certificate open, as well as add private key. So it's going to be there. Now I'll select the private key has to be this one. The certificate has to be this one. Now it will try to connect with this as the thing name. This also needs to be exactly the same. Now there's a button here on the display. If you see, when I enable it, it will start the timer. This timer will kick in this lower block of code, which will try to get the values from the environmental sensor. Click on units env, you will see these are the metrics that is coming from the unit that I have added. So I get those values, also a timestamp and the thing name. Now, once we get this, like let me upload this program. Okay, so that's getting uploaded. And as soon as my device gets restarted, I should see those messages coming into IoT Core. Where do I look for messages? So IoT Core also has something called as like a test client. So when you click on that and then subscribe to the topic where I am publishing messages. So if we see here, I'm publishing to this topic called Core 2 PUP. Let me copy that and then subscribe to it. Currently the messages are not coming. Let me enable that button on my device. So once in every, how many seconds? 5 seconds, because I have started this timer with 5 seconds. I should see those messages coming in here. Now, as these messages keep coming into my IoT core, how do I act on top of it? That's where we can go to act, and then we can click on rules, create a rule. Now, in that rule, we can select what fields of the JSON do we want. Maybe let's say if I want from this topic called core2 underscore pub, call this save to DynamoDB. And we can select what action do we want to perform. Store it to DynamoDB, trigger a Lambda function, forward it to SNS, or do a number of things. So I'll select DynamoDB and it will go, it will ask like which DynamoDB table. Okay, let's put it in, I'll create a new one. I don't know which one do I have so far. Okay, create table. Let's call this like core to data. Environment data. Now I know that I get a timestamp, and this is how the JSON key for that looks like. Do I still have it? No. But I think like it was timestamp. Let me make sure. Go to test again, and I'll subscribe to this topic. Since the device is still sending messages once in every 5 seconds. Okay, that's timestamp, and let's say the secondary key to be device ID. So I'll say sort key to be device ID. Timestamp the number because I'm sending the Unix time from there. So that's a number, and this is a string, and I want that to be saved. Now, if I let's refresh this env data, and when I go to view items, it may not have any items so far. So scan run, no items. I go back to my IoT core. Here I'll select, I want my data to go into this env data. Timestamps a number that has to go in, and partition key value is timestamp in the sort key that is device ID. I need to select a role that lets IoT core talk to um, DynamoDB, env data to DynamoDB role, add action and create rule. I'll have to just wait. Please try after a few seconds. Let's say that was few seconds, but if whenever the messages come and the rule does not work, we can also have an error action which could store those messages in one of these resources again. Okay. Now it has been few seconds now. The rule is created, and let me enable that. So in a few moments, if I go to DynamoDB and then scan it again, I should see the data coming in. Shouldn't it? And I'm still getting those messages here. Let's see. Yes, I get those messages. I think it has been closed like this. It saved to DynamoDB from, let's say, any topic. Add action. So DynamoDB, configure it. Should go to this one and then create a role. Save to DynamoDB. And the action. Create the role. It wants me to wait a few seconds. Okay, now that's done, and then enable it. So I don't know why this wasn't working. Let me disable that, but I'm positive that the second one will start sending data. So that's how it goes. It comes to my DynamoDB. From there, like I can do any processing, run a batch job, get the average of it, and put that into a dashboard. I wanted to like show a lot of stuff like I created a dashboard web page where we can access those data points, and then maybe look at a web page, look at the data in QuickSight. So there are a number of things that we can do, but in interest of time, I'll stop it here. And if you have questions, I am open for that.
Am I audible now?
Yeah.
So yeah, hey, wonderful session question that I have and also our viewers have is how does one get started with AWS IoT?
Okay. So with AWS IoT, I would say, let me share my screen again. So where I got started with AWS IoT, to be frankly, it was AWS.training. So there are a few courses in there. So you can just go to learning library. Now this is changing to skill builder, but if you try to search for IoT, there are a few courses there. If you already know what IoT is, how it works, I would say that this resource will be like a good place to get started with introduction to AWS IoT. And for edge computing, how will that work? And how can you create a free RTOS firmware for ESP32 or whatever device you are comfortable working for? So there's a bunch of resources available here. And the other resource, if you are even new to IoT as well, we recently did this AWS user group, or there is this reskill platform, right? It's not, it's reskill, AWS reskill. So it should still have this dive into AWS IoT. This challenge ends in like it's available till December 31st. So this is again a few videos I recorded that helps people understand the basics of IoT, IoT core, what's green grass, how they can use IoT analytics, visualization of data. So it covers a lot of stuff. I think it's about 3.5 to 4 hours of video, but split into 4 parts. So yeah, this will also be like a really good resource to get started with.
We have please cover some details on Greengrass on AWS.
Okay. So I go back, sharing my screen. Now, it's the presentation here. What we want to do is like when I said edge computing is about bringing some aspects of cloud into the local environment. So what we do is like we nominate one of the devices as a core device where we run this green grass service, basically a script running as service. Now, what does that core enable us to do? It allows our devices in the local premises to talk to each other, whatever number of devices, in a very secure way. And the way these devices can talk to each other, there is something called as subscriptions. So we create those subscriptions, which ensures the right device has the permission to talk to the other right device. And these devices, like when they cannot perform something, or data from multiple devices have to come to a common platform to ensure an algorithm is run, we can run Lambda functions on this Greengrass core device. And if we want the core to talk to third party services, maybe it's like it happens a lot in industrial automation stuff, which is the device has to talk to like a PLC or a SCADA system or other components of the factory environment. Now, that's where these connectors come into picture that allows the core or the IoT devices to talk to like uh, predefined third party applications or protocols. Now, when I said like multiple devices can talk to each other and they can send data to core, and that can trigger a Lambda function, which means can we also do some kind of edge intelligence, like do some kind of machine learning inference here? Yes, definitely. That's what resources talks about. The resources that we can have on a core, it could be a database, it could be files, it could be machine learning models. Now, we can do machine learning inference on the core. It also depends on like what capacity the core has. The core, I mean, the CPU cores, the RAM and stuff like that. And the Greengrass core will be able to do that. According to AWS, core will be one of the other AWS IoT thing, just like how all the other devices are going to be there. But core has much more capabilities, which means even if this entire implementation of several devices, connectors, Lambda functions, all within the core, they completely get disconnected from the internet, this infrastructure will still be functional if the core is running. So that's what Greengrass brings in. one example of how we can use green grass is like there can be factory equipment, PLC, windmill, databases. It could have been any of those things. They can talk to AWS IoT Greengrass directly as an IoT device or through a Lambda function, and the Greengrass can like consolidate the messages, encrypt the messages. It could do whatever it has to do locally to perform the action. A lot of people, they have some local storage. Some people prefer to have like a local dashboard also here, because the data they want to look at in the factory environment, that does not necessarily have to come from cloud. When we have capability of running greengrass service, where can greengrass service run? It could be as simple as your Raspberry Pi, or you can install greengrass as a service in one of your machines, like Windows, Linux, Mac computers, as a microservice as well. In Docker, there's a Docker implementation for greengrass. You can download and then you can enable it. So greengrass as a service runs, and that allows us all the features that I was talking about earlier. And Greengrass can directly talk to IoT Core or any other service on the cloud side. So this is the cloud side, and this can be the on-premise side. I hope that answers your question.
Yes, Sufian, I guess that is it for today. So this was a really amazing session. As you can see, our viewers liked it. And thank you so much for joining us, everyone, today. Thank you so much, Sufian, for enlightening us about AWS IoT. Uh, and for viewers, if you want to watch this video again, this will be available on our YouTube channel. So do subscribe. We keep posting videos. Uh, and thanks again.
Thanks for having me, Karthik. Thanks everyone for joining in. I hope to see you somewhere around in the world. Thank you. Bye.
Bye, everyone.